The Have Blue project was a secret American experimental program developed during the 1970s to demonstrate that an aircraft could be designed to be extremely difficult for radar to detect, laying the scientific and technological foundation for modern stealth aviation. The origins of the program trace back to the strategic concerns of the Cold War, when increasingly sophisticated Soviet radar systems and surface-to-air missiles made it progressively more dangerous for conventional aircraft to penetrate defended airspace. Military planners began searching for a revolutionary solution that would allow aircraft not simply to fly faster or higher than defenses, but to avoid detection entirely. The scientific roots of this concept came from theoretical work on electromagnetic wave reflection. Radar systems detect objects when radio waves bounce off surfaces and return to the receiver, and researchers realized that if an aircraft's shape and materials could be designed to scatter these waves away from the radar instead of reflecting them back, its radar cross-section could be dramatically reduced. A crucial breakthrough came from mathematical studies on how electromagnetic waves reflect from faceted surfaces, which suggested that a shape composed of flat panels, angled in precise directions, could redirect radar energy away from the source. Building on these insights, engineers within the highly secretive Skunk Works division began developing an experimental aircraft specifically designed around radar invisibility rather than traditional aerodynamic efficiency. The result was the Have Blue demonstrator, a small, angular aircraft whose strange geometry looked radically different from conventional planes. Instead of smooth curves, it used sharply angled flat surfaces arranged to deflect radar waves. The aircraft was also coated with radar-absorbing materials that converted part of the incoming electromagnetic energy into heat, further reducing reflections. Because the design prioritized stealth rather than stability, the aircraft was inherently unstable in flight and required advanced fly-by-wire computer control systems to remain controllable, an innovation that would later become common in modern fighter aircraft. Two prototypes of the Have Blue demonstrator were built and tested in the late 1970s under intense secrecy at remote test ranges. During these tests, engineers confirmed that the aircraft's radar signature was dramatically smaller than that of conventional planes, validating the theoretical predictions that had inspired the program. Although both prototypes were eventually lost in separate accidents, the experimental flights successfully proved that stealth technology could work in practice. The lessons learned from Have Blue directly led to the development of the first operational stealth combat aircraft, designed to apply the same principles on a larger scale while incorporating improved flight control systems and mission capability. The project therefore represents a turning point in aerospace engineering, marking the transition from traditional aircraft design toward a new paradigm in which controlling electromagnetic visibility became as important as speed, maneuverability, or payload. Over time, the ideas pioneered in Have Blue evolved into more advanced stealth technologies, including improved radar-absorbing materials, more aerodynamically efficient low-observable shapes, and integrated electronic warfare systems. Later stealth aircraft adopted smoother, blended surfaces and curved geometries made possible by advances in computational modeling that allowed engineers to predict radar reflections more precisely without relying exclusively on faceted shapes. Nevertheless, the conceptual leap demonstrated by Have Blue, treating radar detection as a design problem that could be solved through geometry, material science, and computation, remains the cornerstone of stealth technology. The project also illustrated how interdisciplinary science, combining physics, mathematics, materials engineering, and computer control systems, could transform military aviation. What began as a risky experimental program with unconventional prototypes ultimately reshaped air combat strategy by enabling aircraft capable of penetrating heavily defended airspace with minimal detection risk. In this sense, Have Blue was not merely a prototype aircraft program, but a technological proof of concept that initiated the stealth revolution, influencing decades of subsequent aircraft development and redefining the relationship between aircraft design and the electromagnetic environment in which modern warfare takes place.